this module, we're going to delve a little deeper into object-oriented programming. We're going to learn about concepts such as encapsulation, abstraction, and packages. So let's begin. In this module, we'll be discussing a wide range of topics, from abstraction to encapsulation to the use of packages to organize our classes. We'll learn the difference between a class and an object, as well as how to access member methods and attributes of the class, and learn what a constructor is. We'll learn the difference between private and public access, as well as how to use the Java Technology API online documentation. Before we begin our in-depth discussion on Java, let's take a look at a little bit of the history of where we've been and what has led us up to the Java technology. So if we move our slider over to the 1940s, we see that in the 1940s, programmers were coding in machine code. That's the raw ones and zeros that the computer understands, because that's all a computer understands is ones and zeros. Now this was very, very difficult for programmers to master. I mean, can you imagine that having to know that 1011 meant to add two numbers together? So programmers developed the assembly language, which was three-letter words for the different codes that the machine understood. So for instance, ADD, to add two numbers together, would translate into 1011, which was the machine code. Now this helped greatly, but that still wasn't enough. It was still very difficult to program. So move our slider to the 1950s. Here we started to get some high-level languages like Fortran, Lisp, C, and COBOL. What these languages started to do was group these three-letter acronyms into even higher level functionality. So for instance, one of the common tasks that many programmers had was to print something to the command prompt. So in C you might have a print statement, and the print statement would break down into the 50 or so assembly language commands, which would print something to the command prompt, and those assembly language commands would break down into the machine code. Now what this is this is a form of abstraction. We are abstracting or hiding the details of how something gets done. So first we went from machine code and hid the machine code from the programmer through the use of assembly. And then we hid the tedious assembly code to the programmer in the language like C through the use of functions. And we see this concept of abstraction all the way up to higher and higher level languages. So let's move to the 1960s. And here we start to see the emergence of some higher level operating systems such as Unix, the Mac OS, and Microsoft Windows. And these started to hide even more of the details, allowing us to do windowing commands very easily without having to know all the details. Again, another form of abstraction. Let's move to 1970. Again, we get even more functional libraries, X-Windows, OpenLooks. Now let's move to the 1980s. And now we start to see object-oriented languages begin to come into play. Languages like Smalltalk and Eiffel and C++. Now these languages abstract even more of the details from the programmer. So instead of having to have a bunch of print statements and other types of statements and having to move data in and out of these methods, object-oriented languages bring the data and the methods together and hide them in what we call a class, which we'll be talking about later on. And so object-oriented languages is another abstraction to a higher and higher form. If we move into the 1990s, we see the emergence of Java, and along with it, we see these huge APIs which do a lot of functionality for us and hide a lot of the details, such as Swing with the graphical user interface, and JDBC to access databases and hide the low-level details there. So every time we move up the chain, we try to hide more and more of the details and abstract those details away so we can concentrate on the higher level functionality that we're trying to create. Before you begin coding any object-oriented program, there are two steps that you need to perform. The first is analysis. You need to figure out what the system you're building is going to do. This involves things like modeling the real world, including its actors and activities, and the objects and their behaviors that you're going to have in your system. Once you've completed that analysis, you can move on to design. Design is figuring out how the system will actually do what it needs to do. This involves things like modeling the relationships and interactions between objects and actors in the system, and finding useful abstractions to help simplify the problem or solution. Now, this course is about object-oriented programming, so we're not going to be discussing analysis and design here, but you need to know that these are important steps before any programming project, especially with an object-oriented project. Because of the way that object-oriented programs behave and hide details and try to abstract details out, a good analysis and design is important. It's not only important, it's critical. Here we're going to revisit the concept of abstraction, which I mentioned earlier during our discussion of the history of programming. We want to make sure that you understand what abstraction is because it's an important concept in object-oriented programs. If you can master abstraction, you can create objects that are easier to use and understand and more flexible. So let's take a look and see if we can illustrate this idea. In the beginning, like I mentioned before with languages like C, basically you wrote functions. So for instance, I might have to write a square root function. Then programmers could reuse that square root function over and over again without having to write the underlying code. What we want to do in an object-oriented program is we want to take those standalone functions and the data that those functions worked on, and we want to group them together into a higher level concept, what we call an object. This happens in the real world. For instance, people took mathematical formulas like square root and logarithm and combined them into a calculator so that they could share the data very easily. So we're combining the data and the operations together to create an object. That's basically the heart of object-oriented programming, and it's part of abstraction. We're hiding more and more of the details into a functional unit, and thus making it easier to use. Now, frameworks and APIs go one step further. They take these objects, such as a calculator, and group them together with other functional objects to make things even simpler. And that's kind of the idea of a computer. A computer has a monitor, a keyboard, a mouse, a printer, a scanner, a fax machine, the CPU, all of that combined to form an even greater framework and allow us to do even more complex activities and functionality. So, what you want to do in your own programs is you start with little things, and then you'll build and group those things together, and then build and group even more things together, and that's how you'll be able to create a large system. One of the fundamental things that you have to understand when you begin object-oriented programming is the difference between a class and an object. A class is a blueprint. It's a blueprint for creating objects. Given one blueprint, you can create as many objects of that type as you wish. This happens all the time in housing. Given a blueprint for a house, you can take that blueprint and create as many houses in that style and design with that floor plan as you like. It also happens in manufacturing. You want to create some sort of physical device, you got to have a plan for it, a blueprint for it. And then you can create as many of those devices as you want. So, if a class is a blueprint, what does it tell us? What does it describe? Well, it describes all of the data that each object will have. That is, all of the attributes, or its variables. It also describes all of the behaviors that that object will exhibit. What that means is it defines the methods or the functions that the object will have. Now, there are also three other terms that you're going to have to get a grip on as you go through this course and understand. These are kind of like the three cornerstones of object-oriented programming. These are encapsulation, inheritance, and polymorphism. And we'll be taking a look at each of these in this course. I just mentioned that a class is a blueprint for creating objects. And given one class, you can create as many objects of that type as you wish. So let's see how we define a class and what can go in it. So in our syntax box, we have the syntax for creating a class. The first thing you can have is the modifier. Now, the modifiers are optional keywords that modify the way the class behaves, such as public, abstract, or final. We'll be talking about some of these in this course. Then you must have the class keyword, followed by the name of your class. Now the class name can be any legal identifier as long as it's not the same as one of the Java reserved keywords. It should be a noun in mixed case if you have more than one word in it. For instance, my class. So for instance, my class would have a capital M and a capital C. And you should try to avoid using any acronyms or abbreviations. Then you need the left curly brace and an ending right curly brace, which act as the begin and end of your class structure. Now there are three main things that you can define in your class. The first are your attributes. These are your variables and they hold your data. We'll be talking about these in just a second. The next thing you can declare are your constructors. Your constructors initialize your object, and we'll also be discussing these in this module. And lastly, you can define your methods. This is the functionality of your object, basically your functions. And we'll also be discussing these in this module. There are some other things that can go into a class definition, but we will not be discussing them here. As I just mentioned in our discussion on declaring a class, one of the things that you can define in a class is an attribute. Now you can have as many attributes as you like, but what are attributes and how do we define them? Another thing that I mentioned that you can declare in a class definition are its methods. Now methods are its operations. They are the functionality of the class, or what the class can do. Again, just like with attributes, you declare your methods inside of the beginning and ending left curly braces of your class definition. And once again, order is unimportant. You can put your methods first and then your attributes, or your attributes and then your methods. It does not matter. So let's take a look at the syntax for declaring a method. First, the modifier. The modifiers, again, are optional Java keywords that modify the way the method behaves. Again, some examples are private and public. When you roll over the modifier link, you see the modifiers for the two methods that we're declaring in our class called dog. They both are public, and our methods are called getWeight and setWeight. Now, modifiers are optional, but the return type is not. The return type indicates what value will this method return. Now, if the method does not return a value, then you must specify the keyword void, as we can see in our edit window with the method called setWeight. Now, the setWeight method is not going to return a value, so it is using the void keyword as its return type. The other method, getWeight, is returning a value of type integer, so it has as its return type an int. Now, methods can return only one value or no value. The next thing that you have to provide is the name for your method. Again, it can be any legal identifier as long as it's not the same as a Java reserved keyword. So in our example, our methods are called getWeight and setWeight. And then you must have the parentheses. They are required. And inside the parentheses, you can have an optional list of arguments. These are values that you wish to have passed into the method as input to the method. And you can have as many arguments as you want. You just declare them like you do variables, and you separate them with commas. So in our example, the getWeight method does not require any input. So once I've created this class definition, how do I go about using it? Well, let's take our example of the dog class. When we want to create an object of type dog, we use the new operator. So you can see that in our edit window. We have dog d equals new dog. That's basically using the class file to create a new instance of a dog object. Again, using that class file, we can create as many dog objects as we want. We just say new dog. And then once we've created that dog object, we store a reference to the dog object in the d variable. So that's going to hold our reference to our dog. Using that reference variable, we can then access the methods and the attributes of that object. So in this case, we are only accessing the methods and not any of the attributes. And you can see this in the lines where we call the getWeight and setWeight methods. Remember, getWeight is one of the methods defined in the dog class, as well as setWeight. So we're first going to get the initial weight of the dog by calling getWeight, and then print that out. Then we're going to call the setWeight method, changing the dog's weight. And then we're going to call getWeight again to see that we have successfully changed the dog's weight. And then we're going to call the setWeight again with a negative 42, but the dog's weight won't change because the code in the setWeight method does not allow for a negative value. So then we'll call getWeight again to see that the dog's weight hasn't changed. Each time we access the dog object, we're using what's called the dot notation. We're taking the object reference variable, which is D, that holds the reference to the dog object, and then we use the dot or the period and then give the name of either the method or the attribute on that object that we wish to access. So in this case, d.getWeight to call the getWeight method, and then d.setWeight to call the setWeight method. So it's object reference variable, then the dot, then either the attribute name or the method name. I mentioned earlier that three concepts of object-oriented programming are encapsulation, inheritance, and polymorphism. So here we're going to look at the first of them, encapsulation. Now before we describe what encapsulation is, let's take a look at a problem and then see how encapsulation solves that problem. So here we have a class called myDate, which is declaring three attributes, all of type integer, which are day, month, and year. So it's basically supposed to keep a calendar date. And in the right-hand edit window, we are creating a myDate object, and then we're setting the day to 32, which is an invalid day because no month has 32 days in it. 31 is the max. And then on the next line, we're setting the month to February and the day to 30, which again is, like our comment says, plausible but wrong because February only has 28 days. And then on the next line, we are incrementing the day by 1. Which may be valid, but may not be valid, because if we're at the last day of the month, then we really should go and wrap to the new month, so increase the month by 1, and then set the day to the first day of the month. And this would get even more complicated if it was December 31st, because then you not only have to wrap the month to January, but you have to wrap the year to the next year. So if we allow direct access by the programmer to the attributes of the myDate object, every programmer will have to know all the intricacies of a calendar. They'll have to know what the max days is, how to do wrapping, what invalid days are, what months have which days, etc. So we need to make it easier for a programmer to work with our myDate object. And we can do that by using encapsulation. So go ahead and click the encapsulation tab. Now with encapsulation, what you are doing is you are data hiding. Now you are hiding your data because the data is the valuable thing in a program, okay? It's by far the most valuable thing because if your data gets corrupted, your program is corrupted. So what we do is we make the day, month, and year private. We use the private modifier. So then only methods inside the myDate class can access those attributes. No code outside of the myDate class may access those attributes. No code outside the class can change them or read them. So then what we do is we provide access methods to access that data, to either retrieve the data or change the data. So you can see in our myDate class now we have two new methods. One's called getDay and one's called setDay. So code in another class that wishes to use our myDate object must call these access methods instead of accessing the attributes directly. And then inside these methods, we will have code which will verify things like that the number of days are correct, that any wrapping that needs to occur occurs correctly, things like that. So we can put our business logic inside these access methods, and then other code calls these methods. And we can see that highlighted in the lower right edit window. Now we are creating a myDate object, and now we're calling setDay with a 32, which will return us a Boolean false to indicate that that day is not correct. We will then also try to set the month to February and the day to 30. Again, setDay will return a false, indicating that that day is not valid. And then lastly, we will go ahead and call setDay and increment the day by 1. So using these access methods, we are now protecting our data from getting corrupted. And the myDate object should always have a valid day. This data hiding is what's called encapsulation. Now the third thing that I mentioned that you can define in a class definition are the constructors. Constructors are like methods, but they have a special purpose. They are used to initialize the object at object creation time. So they are only executed when an object gets created, and they allow you a chance to initialize the object. So first, the modifiers. Again, these are optional keywords that modify the way the constructor behaves. And like before, some examples are public and private. Now you have to give the constructor a name, just like you do with any method. But the name of a constructor must match the class name that the constructor is in. So in our example, since the name of the class is dog, the constructor name must be dog. Also notice, we have not declared a return type. That is because constructors cannot return a value. In fact, you do not specify the void keyword. If you specify the void keyword by accident, the method will not be a constructor, it will be a normal method. So that's very important. Do not specify a return type and do not specify the void keyword. Then, after the class name, you will have your parentheses, which are required, and in the parentheses are any optional arguments that you would like to have passed in as input to the constructor to help initialize the object. And then after that, you have your left and right curly braces, which begin and end your constructor just like they begin and end a method. And then inside those curly braces are the statements of Java code that you want executed when the object gets created. So for example, for our dog constructor, we are going to initialize the weight to be equal to 42. Now we have two examples of the dog class. We have the one where we are creating a constructor called dog, and then we have the second one that has no constructor. Now in all of our class examples to this point, we have not been putting in a constructor. And if you do not put a constructor in your class, then the compiler will add a constructor for you. It will be a constructor that takes no input or no arguments and has no code in it. And we can see this illustrated in the comment for the dog class in the edit window below. So once again, to reiterate, constructors are used to initialize your object. You do not need a constructor. If you do not put a constructor in your class, then the compiler will add one for you, which does nothing. Once you do add a constructor to your class, then the compiler will not put the default one that it provides. Now let's take a look at the layout of a Java source file. Now we've already been declaring our class in the Java source file, but there's a couple of other things that can go in there as well. First, we can have a package declaration. If you roll over the package declaration link, you'll see that area highlighted in the edit window. We're going to be talking about package declarations in just a second. And then we can have our import declarations. You can only have one package declaration, but you can have multiple import declarations, and they go after the package declaration. As you can see, if you roll over the import declaration link, we have several of these defined in our edit window. We'll also be talking about these in just a second. Then we have the class declarations, which we've already been discussing. And inside the class declaration is where you put your attributes and your methods. Now, as indicated by the plus symbol, you have to have at least one class declaration in a source file, but you can also have other class declarations. Although this is not common, since only one class declaration can be public and the others cannot. So now that we have an overview of some of the other things that can go in a Java source file, let's now take a look at packages and import statements. In large Java applications, you're going to have lots and lots and lots of classes. And you're going to have a way to organize these classes. So in Java, there's the concept of packages. You group logically related classes into a package. For instance, let's say we had a shipping application, and a large portion of those classes were related to the graphical user interface, and a large portion of those classes were related to reports for the application, and a large portion of the classes were part of what we call the domain objects, such as the company, the vehicles, the trucks, and the boats. So we might want to group those classes into those logical packages of GUI, reports, and domain to help manage these classes. Now this is the same thing that is done in the Java API. There are thousands and thousands of classes available to you. And if there was no logical grouping of these classes, it would be very difficult to find something. So for instance, if I want to do some database functionality, I know to go to the java.sql package because that's the SQL classes. And I'll find all those classes have something to do with accessing a database. If I want to work with networking, I will go to the java.net package. Or if I want to work with input and output, I'll go to the java.io package. So these logical groupings, these logical packages, help us maintain and manage our code. So how does one put a class into a package? Well, it's very simple. You use the package statement. Now the package statement must be the first statement in your source file, and you can only have one package statement in a source file. So a class may only be inside one package. Now the names that you use for your package are hierarchical and map to the directory structure. So you begin with the package keyword, and then you give the top package name. For instance, in our example, we have shipping. And then you can use as many sub-package names as you like. And you separate the package name to the sub-package name by using a period. So for instance, in our example, we have package shipping.domain, which means the vehicle class is going to be in the shipping.domain package. Now this maps to a directory structure. So it means that the vehicle class file, vehicle.class, will be in a domain directory, and that domain directory will be in a shipping directory. Now we'll see this illustrated in a slide in just a second. Once you've put a class inside of a package, you've grouped that class with those other classes that are in that package. And you've isolated it from any classes that are outside of that package. So if one class wants to use another class from a different package, it must use an import statement to import that package into that class file. So it's very simple. After you have your package statement in your source file, if there is one, you would then have any import statements to import any classes or other packages into this source file. How do you do that? Well, you use the import keyword, and then you give the name of the package that you wish to import and either an individual class name or the asterisk. So you may import one class from another package or the entire set of classes from another package by using the asterisk. So in our example, we are importing three different packages. We are importing the shipping.domain package, and along with it, all of the classes in that package. We are importing the java.util package, but only the list class in that package. And then we are also importing the java.io package and all the classes inside that package. Now the import statement works differently in Java than in some languages. The import statement does not bring any of the code over from those other classes. It just allows access to that package. So when Java needs to look up a name, such as a class name, it just uses this list of import statements as a search path to search in those packages for that class. So import statements do not increase the working memory that it uses. It does not increase the final output class file that gets created during your compilation. It's just basically telling the compiler where to look for additional classes that you might be using in your code. Now it also does another thing. You see, when you put a class inside of a package, you basically are changing the name of that class to be the package name plus the class name. So for instance, our vehicle class, because it's in the shipping.domain package, is really called shipping.domain.vehicle. So, by using an import statement, we can just use the name vehicle instead of specifying shipping.domain.vehicle as the full name of the class. So we can in essence use what's called the short name. If we don't want to use an import statement in our source code file, we can use the full class name of shipping.domain.vehicle. But this would be quite tedious, and as programmers, we don't do it if we can avoid it. It's very important to understand the relationship between package names and directory structure. When you declare that a class will be in a certain package, you must make sure that the compiled class file is in a directory structure that matches that package structure. So for instance, our vehicle class we had declared was going to be in a package called shipping.domain. So the vehicle.class file must be in a directory called domain, which would be in a directory called shipping. In other words, the shipping directory will have a domain directory which will have a vehicle.class file. The same thing goes for the company class if we put it in the shipping.domain package, the river barge class, and the truck class. If we had a class called vehicle capacity report, which we put in the shipping.reports package, then the vehicle capacity report class would have to be in a reports directory that is in a shipping directory. Now the question is, where is the shipping directory? And the shipping directory can be anywhere. It can be in any subdirectory that you want it to be. It can be off of a root directory. It can be on a network drive. That's the beauty of Java. You can put this subdirectory tree anywhere you want. And this directory subtree will get tied into your program through the use of the class path, which we will not be talking about in this module. Let's take a look at an example of how you may want to lay out your source code and compile it to the correct directory structure for your packages. So here we have a directory called Java Projects. In that Java Projects directory we have a shipping project directory, and inside there we have a source directory. This is where our source code, or in other words, the .java files will be placed. Now notice we've placed the source code in the same directory structure as our package structure. So in this source directory we have a shipping directory, and in that shipping directory we have a domain, GUI, and reports directory. And we'll put the .java files in the correct directory for the package that .java file is in. So for instance, if you click the domain directory under shipping source, you will see that it has company.java, vehicle.java, riverbarge.java, and truck.java in it. If you click the reports directory, it will have vehicle capacity report.java. So we have our source code in the source subtree. Now when we compile our source code, we would like the compiled class files to be placed in a directory tree that matches the package tree. But we would like those class files to be in a different part of the directory structure. As you can see, under the shipping project directory, we have a classes directory. This is where our compiled code will go. This just makes it easier for deployment. In the classes directory, we want a shipping directory that has a domain, a GUI, and a reports. Again, this is required to match our package structure. Now notice it doesn't matter where the shipping directory is, so we can put it in any subdirectory, but here we've chosen classes, which is under shipping project, which is under Java Projects. Again, the subtree structure just has to match the package structure, but the subtree can be placed anywhere. So then, when we go to compile, we will make sure that we are in the source directory of the shipping project. And we will issue the javac command with a -d option. The -d option specifies what directory you want your output class files to be placed into. So in this case, we want them to be placed in one level up to the shipping project and then down into the classes directory. So we will use the /classes path. And then we give it the path to the .java files that we want compiled. So in this case, we want the Java files in the shipping/domain directory to be compiled and placed into the classes/shipping/domain directory. And this is illustrated in our little animation where we see our .java files compiled into .class files, and then placed in the classes/shipping/domain directory and /reports directory, respectively. Now, once we have our classes compiled into a directory structure that matches our package structure, it's time to deploy our program. Now, the easiest way to deploy our program is to take this entire directory structure and all the class files and zip them up into what's called a jar file. It's basically a zip file with a .jar extension. Now, this jar file will also have a file in it that will tell Java what class holds your main method. And by doing this, then, this jar file becomes an executable jar file. Java can then take this jar file and find out what the class is that has the main method and then begin execution of your program. So we are able to basically copy around one file, that is the jar file, and people can then execute it using Java. So how do we create this jar file? Well, we use the jar utility, as we can see in the command prompt example. We give the jar utility the C, M, and F options, and then we give it the name of a file that contains our main class specifier. So in our case, it's temp file. And you can see this temp file over on the left-hand side. It has main-class, and then the package name and class name of the class that contains the main method. This is so Java can find the main method and begin execution. And then we give it the name of the file that we want to call our jar file. So in this case, myprogram.jar. And so the jar utility will then take the class files and jar them together into a jar file. Once we have that jar file, we can then go ahead and execute the Java command. But now, instead of giving the Java command the name of the class that holds the main method, we give it the -jar option, and then the name of the jar file, along with any path to the jar file. So now the Java command will open the jar file, find out what the class is that has the main method, and begin execution. In this module, we cover a lot of topics and we're introduced to a lot of terminology. So let's just quickly go over some of the terms we learned as a way to recap. First, a class. Remember, a class is a blueprint. It's a blueprint for creating objects. Second, an object. Remember, an object is an instance of a class. So every time we use a class and the new operator, we get an object created. Third, an attribute. An attribute is a variable. It's a data holder. It's part of an object and is declared in the class structure. Fourth, a method. A method is an operation of an object. It's something the object does. It's a function or a procedure. Fifth, a constructor. A constructor is used to initialize an object. It's very similar to a method, but is only executed when an object is created. And lastly, package. Remember, a package is a way to group logically related classes together. Now, you're going to be creating a lot of classes and grouping them into packages. And there's a lot of work for you to do in any Java program. But luckily, Java already has pre-built thousands of classes to help you. So instead of reinventing the wheel, you're going to reuse the classes Java has already built. Now, where do you find out information about these classes? Well, you use the Java API. One, you can either access it online from the java.sun.com website, or you can download it from that website and access it locally. If you want to take a look at it online, you can go ahead to the link that we have displayed here, java.sun.com/j2se/1.5.0/docs/api/index.html. Once you go there and you open up the API help, you'll find a screen that's similar to this. This is broken into 3 different areas. In the upper left frame, we have the packages listed out. If you click one of the packages in this frame, the classes in that package will be displayed in the lower left. And if you click one of the classes in the lower left, the class itself will be displayed in the main frame that takes the right-hand portion of the window. Now, there's a lot of information that gets displayed for a class. You get the package that the class is in and the class name. So, for instance, we're showing you the string class from the java.lang package. You also see what classes that class is inherited from. So in this case, the string class is inherited from java.lang.object. We haven't talked about inheritance yet, but we will. We also see the interfaces that are implemented by this class. Again, we haven't talked about interfaces. We also get a description of how to use this class. And you'll get a listing of the constructors of the class, the methods of the class, and any attributes of the class. So go ahead and go out there and explore the API help and get used to it, because this is a good resource and it takes a little while to get a feel for how to navigate around it and what information it's providing you. In this module, we learn about object-oriented concepts such as abstraction and encapsulation. We also learned how to use packages to organize our class files. We learned what the difference between a class and an object was, and how to declare member methods and attributes, as well as constructors. We learned the difference between public and private access, and also how to use the Java Technology API online documentation.